Okay, so again, if you're feeling comfortable with degrees, please pause here, try and sketch these, and then you can go back and check your answers and just come back and watch if you need to. Let me just peek at, I didn't give you very good directions here. I want to do, yeah, I want to do a couple of things here, even though I didn't say it, I don't think. I want to sketch these angles, and then I want to talk about some coterminal angles. So, and I'd like to add that to your try it now problem as well. The answer key should have the coterminal part, but it doesn't look like I put any directions for that. Okay, so 60 degrees. We talked about 30, so let's see, what do we have here? So if pointing straight up would give us our 90, so it's not that ray is 90, but the angle that would get us there is 90. We want to be able to divide this into thirds. So I gave you this polar graph paper to make this easier. If you count these out, we got 1, 2, 4, 5, 6 of them. So that divides it into 6. So this would be a third, and this would be 2/3. So a third of 90 would be a 30-degree angle to get me here, and 2/3 of 90 would be my 60-degree angle. So to get a 60-degree angle, I need a ray that points right out there. So this is the actual angle. So you'll see this sometimes where we label the angles kind of just at the location of their terminal side, but we hopefully keep in our mind that the rotation is actually the angle. So that's a 60-degree angle. And one of the things I want you to be able to do just to practice to get good at this is think of coterminal angles. So usually easy ways to get coterminal angles would be to, oh, yikes. Excuse my scroll. Just keep going more times around, but I want you to be able to get positive and negative. So for example, a positive one, if we do a full rotation and then an additional 60 degrees, that would be 360 to get around and another 60 to get back up to our location in the first quadrant. So 420 degrees, hopefully I don't do any bad addition while I'm on this, would be a coterminal angle. If we wanted to go negative, we can get one of those that's not even all the way around yet. So to think about that, we went almost all the way around. We stopped 60 degrees shy of a full circle. So to get to this ray, we would need 300 degrees. And again, just to make sure I'm being clear about that, the reason I know that is because if I went this far, 300 degrees, and then this additional 60 degrees, that would be 360. And because of my direction, that's going to be a negative 300 degrees. And so it gets kind of hard to, here, let me see if I can pull out one more color here for you. Color, maybe like a bright green. Will that show up well? Okay, so for that one, if we wanted to do all the way around and then an additional 300 degrees, so that one I went all the way around 360 and then another 300, so that's 660 degrees, and because of my direction, that's going to be negative. Okay, I might not do all those coterminal for all of these because I think I might drive you nuts with all my talking, but we'll at least do a few. Let me go back to my original color. Dark blue. Okay, so negative 135 degrees. So it'll take a little getting used to spotting some of these, but generally they're all going to be multiples of 30 or 45. So this one with the 5 on it makes me think it's going to be 45. So I'm going to think about this as, okay, so if I go 0, and then out here would be 45, and then I get to 90, and then if I go another 45, 90 plus 45 should give me exactly what I'm hoping for. Is that the middle one? Yep. 135. Okay, but I'm being kind of silly because these were negative. There's not really any reason I needed to do them at the top. I was just thinking that way. So let's go negative 45, and then we'll go negative 90, and then over here, so this rotation is negative 135 degrees, a little more than a quarter of the way around the circle. Okay, so again, if you subtract 360, you're going to get a coterminal angle. What's that? 364.95, negative 495, I think. Don't always trust my arithmetic, but that would be the idea. If you want to go the other direction, there's really two ways to think about that. Really, you're taking negative 135, you're adding 360, so you can always just add or subtract multiples of 360. But intuitively, using the graph to get these two that add up to 360 is really nice. So when I look at this, I can say, okay, I went a little more than halfway around. I know that to finish my lap would be 135 degrees. So I'm going to do 360 minus 135. And since I don't trust my arithmetic, I'm going to go ahead and do it carefully. And this looks like it's going to be 225 degrees. And then if you wanted another positive, just add 360 to that 225. Okay, 390, practice with some of these bigger angles. So I know that all the way around is 360. So I just need to go an additional 30 degrees from there, which we decided puts us right here. So this whole thing should be my 390 degrees. Notice we get kind of an easy coterminal here. We can hopefully spot the way we did that this is going to be 30, and that is coterminal. We could also go the other direction, and we could say, okay, that's not quite 360. We stopped 30 degrees shy of 360, so that's 330 degrees. We could certainly start subtracting, negative 330. That was seeming weird in my head, and that's why. We could subtract another 360, so we get negative 690, I think that is. So just multiples of 360 to get your coterminal. Okay, one last one here. Negative 480. Okay, so we're going the opposite direction. So all the way around, that's 360. And then I need to go another 120. So let's see, 360 plus 90. So now I'm up to, I can't keep these numbers in my head. 360 plus 90 is 450. So I need another 30, which is two of these grid lines. Okay, so the whole round and round and round is my negative 480 degrees. Notice, again, there's kind of a, quick, easy coterminal here, or I think an easier one. That was 90, and then we ended up needing to go another 30, so that's negative 120. That would be coterminal. The positive angle that's less than 360 is 240. 240 plus the 120 we just had would add up to 360, so 240. And then from either of those, start adding and subtracting 360, and you should be able to get even more of that. Okay, sorry, I know this one is a little bit long, but I just want to throw this in because it fits so nicely rather than breaking it off on its own. Last thing, I've already said this, but I just want to make it really clear. We want to be really good at all the multiples of 30 and 45. So I would just say start trying to count by 30s and 45. So if this is 0, then this is 30, 60, and even without the grid, just this idea of we know 90 gets us a quarter of the way around, so we're doing 3 30s to get to 90. And then 90 plus 30, this is 120. 120 plus 30, this is 150. And then 180, hopefully, is a really easy reference point for us. 180 plus 30 is 210. 210 plus 30 is 240. 270. 300. And then 330 and 360. Okay, so we should be really trying to get good at being able to count those out. And then similarly with the 45s, I tried to switch colors, there we go. 45, 90, we did this one before, this one would get us out to 135, and the 180. So notice some of those multiples coincide. Right out here in the middle, what are we doing? 180 plus 45 is 225. and then we hit the 270, and then what are we getting there? 315. And then our 360. Okay, so we want to get really good at that. And if you use like a unit circle graphic for reference, sometimes that's okay. But again, remember the goal is to get fluent. We don't want to be having to refer back. We want some memorization to happen. I don't want you spending gobs of time just memorizing everything, but this idea of counting by 30s and 45s should hopefully be helpful.